Chapter 5.3. We will continue with binomial probabilities, and we will be continuing with the table that we left off with on the last section. So be sure that you have the binomial table available to you. Now what we're first going to look at is how to graph one. It's a histogram, so that tells me the bars will touch. Each of the R value, and remember R is your number of successes, will be on the horizontal axis, and then the probabilities, which are found on the table, will be on the vertical axis. So if you will turn to page 219, we're going to look at number 11. Let me get that open myself. Page 219, number 11 reads, Old Friends Information Service is a California company that is in the business of finding addresses of long-lost friends. They claim to have a 70% success rate. Suppose that you have the name of 6 friends for whom you have no addresses and decide to use the Old Friends services. Okay, so the trial is each friend. And how many friends are you wanting them to find their address? 6 of them, so that's why N is 6. We consider success when they find the address. Now, in this case, I don't have to calculate the probability of success. It is given. They tell me it occurs 70% of the time, which is 0.7. So we're looking for N is 6 and P is 0.7. So if you will go to your binomial table, and again, N, we want 6, and then P, which is at the top, P is 0.7. So if you'll follow down, and I've actually highlighted those values in blue. So this is the probability that 0 friends' addresses were found, 1 friend, 2 friends, 3 friends, 4 friends, 5 friends, and 6 friends. And those are the numbers that we are going to need in order to create our graph. So just like I showed you on the table, those are the numbers that we're going to put here. So we had 0.001, and that means they didn't find anybody. 0.01, they found 1 address. 0.06 is finding 2 of the addresses. 0.185 is finding 3 of the addresses. 0.324 would be finding 4 of them. 0.303 would be finding 5 addresses, and 0.118 would be the probability that they find all 6 friends' addresses. So if you'll notice, I've already set up a horizontal and a vertical axis. Here's my horizontal, which is your R, or your successes, so 0 successes all the way to 6 successes. And then the vertical axis is your probability. So on 0, it was 0.001, which is barely up there, because 0.01 isn't very tall either. So that's why I put the number above, because my actual drawing is a little off. And then we have 0.06, and then 0.185, .324, .303, and 0.118. And then again, don't forget to label your axes and also title your graph if you're asked to create a graph. If I ask you the distribution shape of this, although you do have 2 bars over here, it more tapers to the left, so this would be considered skewed left. So that is problem number 11, and this is the histogram. Now, one of the things that you will also be asked is, based upon the information given, how many addresses would you expect them to find? Well, if you remember from our previous discussion, when it says expected, that means to calculate the mean. So in this case, and this is the formula you use for the binomial distribution, the mean is n times p. So N is the number of trials, P is the probability of success on a single trial. The standard deviation, sigma, is the square root of N times P times Q. So we're going to use that same problem. So we had 6 friends. We wanted addresses to be found. They told us that per person, there's a 0.7 chance of finding their address, which would make this 0.3. So if we were asked what is the expected number of addresses or how many addresses do I expect them to find, that's mu, which is N, times P, which is 4.2. So I expect them to find 4.2, or basically 4 addresses. The standard deviation would be the square root of N, which is 6, times P, which is 0.7, times Q, which is 0.3. Now, where you need to be very careful here when you do this calculation, I have students do this all the time. They will multiply, and they will multiply, so in this case it would be 6 times 0.7 times 0.3, and they get 1.26. And then they stop there. Well, you still need to find the square root of that. So be sure that you're finding the square root of that multiplication and not just that number. And that's approximately 1.12. So my mean is 4.2, and my standard deviation, that you can't really see, there it is 1.12. So we're going to do 2 more problems that are application, so you can see how these problems might be worded and how to pull the information out. So this reads, in a pharmaceutical trial, 60% of the men tested remained bald. Okay, after using Rogaine. The cream will be tested on 5 men, so the trial is each man, and there are 5 of them, so there's 5 men who have male pattern baldness. How many men do you expect to remain bald? Since they're talking about remaining bald, that's why I define that as success. What is the probability of success on an individual trial? 60%, or 0.6. Well, if P is 0.6, that makes Q be 0.4 because these two have to add up to 1, and 1 minus 0.6 is 0.4. How many do you expect? That word expect right there tells me, oh, I need to calculate the mean. And for a binomial distribution, to calculate the mean, all I have to do is take N times P, and that would give me 3. So of the 5 men, I expect 3 of them to remain bald. Now this particular problem did not ask for the standard deviation, so if it doesn't ask, you don't have to calculate. But I'm going to go ahead and let's calculate the standard deviation just so you can see that worked. So that would be 5 times 0.6 times 0.4, and then take its standard deviation. So 5 times 0.6 times 0.4 is 1.2, but that is not my answer because I then have to take the square root of that and get 1.095 or 1.10. All right, one more example, and that will complete 5.3, and it also will complete Chapter 5. A dealer considers a car to be successful if it doesn't require repairs covered by the warranty. If the probability of a car being successful is 80%, so there's my success right there, so I bet that goes right there. Find the mean and standard deviation for the number of successful cars among the 3 cars sold in one day. So the trial is each car. How many of them? 3. What do we define as success? It doesn't require repairs. They told us that occurred 80% of the time, or 0.8. And since P and Q have to add up to 1, 1 minus 0.8 is 0.2. And then it asks us to find the mean and the standard deviation. So the mean is N times P and 3 times 0.8 is 2.4. So I would expect 2.4, or basically 2, sometimes 3 of the cars are not going to require repairs. Now that can deviate by the standard deviation, which is the square root of 3 times 0.8 times 0.2. And let me see what that is. 3 times 0.8 times 0.2 is 0.48. But again, I have to take the square root of that. And the square root of 0.48 is approximately 0.69. So there is your mean, mu. There's your standard deviation, sigma. And both of these are population parameters. That is 5.3.